compositional functions, there is some restrictions for the domain. You can just view here. F is a function defined from x to y, and G is defined from y to the set Z. You just notice that what is the restriction given here is, here this codomain of F is the same as the domain of G. Then composition of the function which is denoted by G dot F is defined. G dot F is defined from X to Z, such that now we are talking about from where to where G dot F is defined. And the second part is what is the image of any element X from the domain of G dot F. It is defined as G of F of X. This you have studied yesterday. Now my question is whether G dot F is the same as F dot G. G dot F and F dot G, whether these compositions are the same. First of all, to define F dot G, what is required? F dot G. Suppose you try to define F dot G, you have to be careful about the domain and codomain. F here hoga, G idhar hoga. So to define F dot G, you should have this element, this set common. That is, the codomain of G must be equal to the domain of F. Then only this G dot F dot G is defined. Okay. So in only on those cases, suppose you have taken G is actually from Y to Z, and if F is defined from Z to some other this thing, then only F dot G is defined. But in this case, F dot G is not defined. There will be restrictions on the set. So in general, we can say that F dot G is not equal to G dot F. Now, the next part is the problem solving. How to find F dot G of some variable X. For example, yesterday we have studied the function f and g, where f and g were written in terms of the set notations like roster form. Now the question is question number 4 of your exercise 1.3. Can write it now. If f of x equal to 4x plus 3 by 6x minus 4, where x not equal to 2 by 3, find f composition f of x. Understood? Now find f dot f composition f of x. So now to find f composition f of x, first of all you will write the definition of f composition f of x. When you remove this composition sign, what will be the change? It will be written like f of x, and that is equal to, first of all you will substitute this f of x, the interior-most image you will substitute. That is, what you have to do first is f of x you will write. It is 4x plus 3 by 6x minus 4. According to question, f of x is 4x plus 3 by 6x minus 4. Now the task is to remove this f. And how to remove the f is, this you have to study and understand nicely. Whenever you are removing x, or the other sense we say, whenever you are writing the image of x, f is removed, right? And how it is removed is, you can see that you are removing, you are getting a rational expression. What is a rational expression? It is 4x plus 3 by 6x plus 4. So here rational expression mein where x is coming, yeah, x is written in this position and x is written in this position. So here when you come to this question, when you remove f, what changes it will take place? You can see that when you are removing x, it becomes 4 into something plus 3 by 6 into something minus x. So this open bracket which I kept for what? It is the variable present here. So see here you have f of x equal to, we have f of x equal to 4x plus 3 by 6x minus 4. So how you are removing this f of x to the rational expression is, in the rational expression there is a space. This space I am writing whatever inside this. So here also what I have done is this highlighted portion I have just kept it like that. This highlighted portion is kept for the expression inside f of x. This is for x. So in this highlighted portion what will come? That will be whatever inside this f of, that will be coming to this place. Okay. So what will be that? So that becomes, this expression becomes, here you will write 4x plus 3 by 6x minus 4, and here also we'll write 4x plus 3 by 6x minus 4. I hope
Ma'am, in
children.
the denominator, it should be minus 4, no, ma'am. I've written minus x.
Yeah, correct. So it should be minus 4. It is minus 4. I hope you understood now. Your LCM is 6x minus 4 in both the place, 6x minus 4, and here it will become 4 into 4x plus 3 plus, you will be multiplying with this here, 3 into 6x minus 4 divided by 6 into, here also your LCM is 6x minus 4, then minus 4 into 6x minus 4. The common denominators you can cancel. And this remaining part is left to you. Minus 1. Find g dot f of x. G dot f of x is the composition of g and f. You can write it as, by definition, it is g of f of x. The next is the interior function you have to write first. That is, what is f of x? So now it becomes, which is equal to g of, you are replacing f of x. It is coming from the question, it is x square plus 1. Next, you have to write what is, we have to remove g of x square plus 1. So now you look at here, when you are removing this g of x to an expression, it becomes 1 by x minus 1. How it is removed is, this x is coming here. So this one you have to understand. So it is equal to, what will be that? When you remove g, you will get 1 by, in place of x, here we have, what is in place of x? G of x का जगह पर हमको है x square plus 1. Okay, so 1 by, you will put here x, then minus 1. Okay, So this x का जगह पर हमारा जो highlighted portion x square plus 1 है. So we'll write here x square plus 1 because you have to correlate these two. When you are removing g of x to an expression, it becomes 1 by x minus 1. And in place of x, here, in place of x, we have x square plus 1. So this is a final answer, and that is equal to 1 by x square. F of x, sometimes it may be given like this. So what will be that? f of x equal to, first you will replace the interior function. Okay, so what you get is f of, instead of f of x you will be writing 3x plus 2, because we know f of x value is 3x plus 2. Now again you have to remove f. Now removal of f you have to study nicely. When you remove f of x to a algebraic expression, what is the changes? 3 into x plus 2. So in place of x, you have to use now here 3x plus 2. So now it becomes 3x plus 2. That is, what is this? X is, x का जगह पर हमारा ये होगा 3x plus 2. It will be 3x plus 2 plus 2. And the final answer is 9x plus 6 plus 2, and which is equal to 9x plus 8. f of x. So now when you remove f of x, or f of x is changed to the rational expression or an algebraic expression, what is the change here you see? So this is the change. In this algebraic expression, you replace x here. So f of x image value will be obtained. So after learning this, let us start with f of x. First, you will write the interior function value. Please write f of x. Very carefully you have to do this question. See, you have to learn how to change this f of x. One f is changed. This is a change. It is happening. That is right hand side expression ka x ka jagah par this place will be replaced with x. So here first part is very easy. It becomes 3 minus x cube raised to 1 by 3. Now the next part, whenever you change f or the image of f, you are getting an expression like this. Let us copy that expression by keeping x, the place of x vacant. This place you keep vacant. Okay, बाकी सब ऐसे copy करना है. 3 minus, that place is kept vacant. So I am putting here this sign. This is a vacant place because that is stands for the point x raised to 3 raised to 1 by 3. When you are changing this image of x under f, this is the expression we are getting. Now this x is replaced in this blank space. So instead of x, what we have here? Inside f, what is that? This full quantity you will be replacing here. ये हमको इधर replace करना है. So what will becomes? It becomes 3 minus x cube raised to 1 by 3. So what will be the simplification? Here we will do the simplification. This expression 3 minus x cube raised to 1 by 3, raised to 3, whole raised to 3. So that becomes something x raised to 1 by 3 raised to 3. When you apply the laws of indices, it becomes x raised to 1 by 3 into 3, and that becomes x. So here one expression raised to 1 by 3 raised to 3. So that becomes 3 minus x cube only. Then there is another raised to 1 by 3. It is 3 minus, this becomes as raised to 1 by 3. So now it is equal to, opening this bracket, 3 minus 3 plus x cube raised to 1 by 3, and that becomes x cube raised to 1 by 3, and it is equal to x. If f of x equal to modulus x and g of x equal to modulus 5x minus 2, also find f dot g of minus 7. So first of all, you have to find f dot g of x. F dot g of x. By definition of composition, it is f of g of x. And now you have to write what is g of x. As per the question, g of x is modulus of 5x minus 2. And when you remove f of x, now the image of modulus 5x minus 2 under f, you have to find out. So here, when you remove this f, what changes it comes? It is modulus of, you have in place of x, modulus के अंदर में whatever it is that you have to write. So it becomes, here it is modulus 5x minus 2. So दो बार modulus ले लो तो you will get the same modulus only. So that becomes only modulus 5x minus 2. Now the next part is f of g of f dot g of minus 7. That means in place of x, you will put minus 7. So it is 5 into minus 7 minus 2, and it is minus modulus of minus 37 minus 35 minus 2, and modulus means you will get the positive value. So 37 is the answer. Question number 5. F of x equal to x plus 7, g of x equal to x minus 7, then find f dot g of 7. So what is that? F of g of x, you will find out first. It will be f of g of x and g of x value first we will replace. So that is f of g of x is x minus 7. And now you have to see that when you remove or when you find out the image, you are getting of x under f, you are getting this expression with x plus 7. So here when you find out the f value of x minus 7, you will be getting some expression x plus 7, and in place of x we have here x minus 7. So this connectivity you should know that how x is changed here. So whatever inside f, that is here x minus 7, that will be coming here, and the final answer is x. X minus 7 plus 7 is x. Now you have to find out the real part, what is asked in the question, that is f composition g of 7. It is f of g of 7, and it's already found out it as 7, because f of g of x is x. So f of g of 7 is, in place of x we have 7. 7 is the answer. So 4-5 questions of previous year papers I've done. Please write fast. Invertible function. For example, just to see, we are defining a function from x to y. F is defined from the set x to the set y. A function f is said to be invertible if there exists a function from y to x. Suppose you just say that there is another function defined from g y to x such that f dot g is equal to g dot f is equal to I, the identity function. You can write this definition. Please write a function. Please write a function f from x to y is invertible if there exists a function g from y to x such that f dot g equal to g dot f equal to I, where I is known as the identity function and the function g is called inverse of is called the inverse of f and is denoted by inverse. This is a notation. Children, it is not f raised to minus 1. It is only a notation. It is just like a figure. I am writing here 1, 2, 3, 4, 5. Here I am writing 1, 1, 2, 3, 4, 5. Okay. Suppose if I am making a mapping, like a function from x to y. Suppose here is your x, here is your y. And I'm just making this. The image of 2 is 4. The image of 1 is 2. The image of 3 is 4. The image of 4 is 5. Okay. This function I'm calling it as f. Or you just say that you are traveling from x to y through this route. Okay, now if you are taking the inverse mapping, what do you mean by inverse mapping? Just see, I'm coming back from y to x. I'm coming back from y to x. From 2, I'm coming back to 1. From 3, I can go back to 2. And from 4, I can go back to 3. And from 5, I can go back to 4. If I call this reverse mapping, it is a relation actually. I'm just calling it as the relation G. I can also call it as relation G. Is this relation G is a function or not? Is this relation G? G is defined from word to word, from y to x. My question is, this relation G, is it a function or not? Is it a function G from y to x? Is it a function or not?
No, ma'am, because 4 has 2 images.
Yeah, correct. So my question is it a function? It is not at all a function, because the definition of function is that every element of the domain should have a unique image. And what is the domain of the function? This present function G. Domain of this relation, it is, see here y. Here this y, 1, 2, 3, 4, 5, and every element should have an image. That is not there. Second thing, the image is not unique. Both the conditions are not satisfied. When you are taking the inverse mapping, it is not a function. Now I can solve this question. In order to make the inverse mapping a function, what changes should I do? ये मैंने change कर दिया. This one I have changed, and I'm just bringing another function. 3 का image 3 है. So that means one problem I have solved, and this 4 का image भी I have to rub it off. 4 का image also I have to rub it off. Okay. So, and 5 का image, this also. So now if this function, if you take the inverse mapping, is it a function? Simply you're just going back like this, 2 to 1, then 3 to 3, 4 to 2, and 5 to 4. Is it a function? Now is G a function? From y to x? Why it is not a function?
Ma'am, because not every element is attached. So
Every
Still 1 is
have the image. That condition is not satisfied. Which element does not have an image?
ma'am, one.
One does not have an image. So again the problem comes. So everything depends on your function f. So your function f was what type of function? Your function f. Is this function, oh sorry, 5 is not there, okay. Is this function what type of function? It is, first of all, it is 1 1 function. Now at the present situation, you can just see that
It
this
is
function
minus 1.
but it is not onto, right? It is not onto. I'm talking about the function f. This function f was 1, 1, but it was not onto because 1 does not have any preimage. So then also you are not able to find out an inverse mapping as a function. A g cannot be a function because f was not onto. So one criteria to make the inverse mapping a function is that the function must be 1, 1 and onto. अभी हमने if the function f is 1, 1 but not onto, because it is not onto, the inverse mapping is not a function. So in order to invert a function, there are two conditions required for f. F must be 1, 1, and second condition is that f must be onto. So when f is 1, 1 and onto, you can invert the function. And suppose you are making this function as onto also with this example. I'm just rubbing it off this. You can see that at present situation f is 1, 1 as well as onto. And you can invert the function, and the inverse mapping which have defining like this: 3 to 3, 4 to 2, and 5 to 2. Now this mapping we call it as inverse of f, and you can denote it by f inverse. Instead of g, I can denote by f inverse. Now simply by arrow diagram I explained, but theoretically when you say how do we write it, you can also notice that the composition of f and f inverse, what it becomes. In the composition idea, I have to take 3 sets, right? Because I'm going to see what is your f composition of f inverse. F composition of f inverse क्या होगा? Similarly, f inverse composition of f क्या होगा? Thus, theoretically, how to change it. So, for bringing this composition, as per the arrow diagram, I am just taking the 3 sets x, y, x. Okay. So, here 2, 3, 4. F is defined from x to y, and you can see that I have defined f inverse from y to x. So, x को एक दूसरा illumination दे दिया है. Here it is f inverse. Instead of putting here f inverse, what I did is this one I have discarded and I have put y to x, x on the right side of y. Okay. Now you can just find out what is the composition of functions, because according to your f, what is the image of 1? You can see that the image of 1 is, I have drawn here, image of 1 is 2, image of 2 is 4, and the image of 3 is 3, and image of 4 is 5. 4 is 5. And I'm taking f inverse as 5 ka image hoga 4. So f inverse I'm taking in the next side. Okay. So I'm taking f inverse. What is the image of 5? Image of 5 is 4. Okay. You can just notice here. Now you can just see the image of 4 under f inverse is 2. Image of 4 under f inverse is your 2. So 4 ka image is 3. Under f inverse it is 3. So image of 3 is 3. Now image of 2 under f inverse, I am going through this way, it is 1. So 2 ka 1. Now each function f inverse composition f, it is defined from x to x. You can see that f inverse is here, f inverse, and here f F inverse x is defined from x to x. And what is F inverse F ka har ek image? 1 ka image, you are going to 2 and then to 1. So image of 1 becomes what? F inverse F of 1. It becomes 1 ultimately. Now F inverse dot F of 2. That becomes what? 2 se 4 gaya, 4 se 2 gaya. So that becomes 2. F inverse dot composition F of 3. You can see as per the composition also, you see F of 3 is here. Here 3 se ja raha hai, 3 aa gaya, fir again 3 aa gaya. Ultimately we'll get 3. So F inverse dot F of 4. You can see it is F of 4 is 5 and from 5 to 4. So finally it is 4. So what you have noticed is the image of 1 is 1 under F inverse F. Image of 2 is 2. Image of 3 is 3. Image of 4 is 4. So in general you can say that F inverse composition F of x is x. So the image of x is x itself. Then what type of function is this? Image of a function is that image of x is x itself. Then that function is what type of function? कोई भी एक function का image, कोई भी एक x का image under g is x. Then g is a special type of function. What's the name of the function? What is identity function? I of x equal to x. Right? Identity function means what? It is the image of x under the function is x itself. Then it is known as identity function. And last year I have studied defined on the set x. Or this is the meaning is that I is from x to x. Ix means identity function. Similarly, you can show that f dot f inverse is also an identity function. That will be an identity function on y.